Thank you, Courtney, and welcome all to the webinar. Bastian's going to move my slides for me, so Bastian, go to the first slide. You've already heard that we're all members of the Highway Capacity Quality of Service Committee, which is the committee at TRB, which is responsible for the production of the Highway Capacity Manual. I'm on chair of one of the subcommittees, the Subcommittee on Performance Measures. There are multiple committees usually geared towards individual chapters and facilities in the HCM, but the Subcommittee for Performance Measures is a cross-cutting subcommittee. We look out for performance measures across all of the chapters to make sure that there's consistency in the use of performance measures between the various facility types that are covered by the HCM. We also are very heavily involved in the creation of multimodal performance measures and try to embed those wherever we can in the various chapters. One of our main charges in the last 2 years has been to incorporate advancements in performance management practice that's taking place out in the field into the HCM. And this takes place in three different ways. Looking at new data sources such as vehicle probe data, such as the NPM RDS and other sources of vehicle probe information, and how that can be used in the HCM. Incorporating new measures, including reliability, which we'll hear about today, and also the MAP 21 measures, which are related to reliability, but other things as well. And we're just really getting started in trying to look at new concepts for performance management, including measuring the performance of entire trips all the way up to accessibility measures, which include the trip and what users do at the various trip ends. So we're just getting started in some of those advanced concepts. Next slide, please. So we've heard a lot about performance management, particularly with the new rules that have been promulgated by Federal Highway. And there's a heavily oriented towards the use of empirical data to look at monitoring of performance, what's happened in the recent past. And there are various functions associated with performance management, including looking at data for MAP 21, identifying corridor performance reports, doing evaluations, and helping to set targets. But in addition to this heavy orientation towards monitoring, next slide, there also is a very real need for doing forecasting to support performance management. And here we're thinking about using forecasting tools as an aid in target setting, in statistical controls and before and after studies for formal evaluations, and also looking at what the impact is of proposed projects on performance measures and how they, especially how they influence progress towards individual targets that have been set. And the HCM really hits the sweet spot for supporting these functions because it's more complex than sketch planning methods and more rigorous, uses more data and is more theoretically sound, but it's not as complicated and cumbersome and data intensive to use as simulation models. So it's right, it's not too cold, it's not too hot, it's the Goldilocks of analytical techniques in terms of supporting performance measurement activities. And now Rick and Bastian are going to take you into the details of how the HCM deals with reliability prediction, and I think you'll see very clearly how it can be used for each one of those particular functions for supporting performance management.
Okay, thank you, Rich, for that introduction. For the rest of the webinar, we really want to cover three primary areas. First, I will give an introduction to the reliability analysis and some of the performance measures, give a high-level overview about the reliability methodologies that are now contained in the HCM, and then turn it over to Rick to talk about some use cases and applications of the methods before we summarize everything. Just one word before we get too much into detail. This is not a webinar on the details of the MAP 21 and FAST-Act performance measures. There's actually one scheduled for later this week by Federal Highway that gives a lot of the details, and there will be more information forthcoming. But many of you may know that the rulemaking has now been published in the Federal Register, and so we will allude to some of that content, but we will not give a full detail of that overview. Our focus, of course, is on the Highway Capacity Manual. So starting with an introduction to the reliability analysis, one of the big things up front and center is that we're not looking at ideal sunny day conditions for the open roadway without really any delay or travel time variability. When we're talking about reliability, that's typically in a situation where we have both reoccurring and non-recurring congestion, where travel times and speeds really change from day to day as a function of a whole number of different factors that influence the performance. And then really the question I would pose is, why do we still analyze the average day? Which traditionally has been the focus of the highway capacity manual, as well as most simulation analyses. Even though we may do multiple random number seeds, we're really condensing everything down to the average travel time along a certain facility. Borrowing some slides that Federal Highway has been using for a few years now, in the top left, we're seeing what that average day looks like. The traditional highway capacity manual framework presumes the same performance, the same travel time from January through December, Monday through Sunday, and clearly that is not the way travel on our freeways and arterials really happens. In reality, we have variability where travel time changes from one day to the next. And what's highlighted here is that really the general public remembers the outliers. So the customers, the clients, we're all serving as transportation professionals. They're a lot less interested in the average day than these outlier events. When we're moving towards now an active traffic management and the performance assessment and implementing strategies, the average travel times are also not necessarily useful anymore, because many of our strategies, whether that is adaptive ramp metering or part-time shoulder use or variable speed limit and a whole host of other non-capital investment but rather traffic management strategies, they may not be geared at improving performance for the average day, but instead really are looking at reducing the variability of travel times or enhancing the reliability. And so in that context, it is very challenging to, again, use the traditional highway capacity manual or simulation framework to account for the effect of all these. And as Rich alluded to in his introduction, this predictive work and the before and after or evaluating different scenarios in terms of their impact of reliability, that is something where all the probe data and the NPM RDS and the various data sources really don't tell us a whole lot based on historical or even real-time data. As agencies are making investment decisions for different strategies, the HCM is emerging as a very powerful tool to assist with that. Specifically, here's some of the sources of unreliable travel. There's the actual variability and demand from a day-to-day basis. We know that demand is different on Mondays than it is on Tuesdays than it is on Fridays. There's also seasonal variability. There are various work zone effects. There are weather impacts. There are incidents. So a whole number of reasons why our travel times vary from one day to the next. Really, the underlying premise of the highway capacity manual reliability method is that we're explicitly evaluating each of the different days over the course of a year. And so the framework is shown here, where the highlighted cell with the black frame is the traditional highway capacity manual framework, single 15-minute analysis in one individual segment. With a corridor signal timing tool as is commercially available, we may be looking at a facility, and then as we're going to a simulation-based analysis or even the HCM freeway facilities method, we're already looking at an extended time-space domain here. But really the key addition and what's new in the HCM 6th edition is that we're now adding the reliability dimension, where we're modeling each individual day of the year, 250 working days, with varying demands and capacity inputs with underlying probabilities that describe incidents, weather, as well as work zones. After we've completed that analysis, really all the results are compiled into what we call the travel time distribution. And really this is the underlying premise of some of the MAP21 and FASTEC performance measures, as well as the HCM reliability method that we're talking about today, that the average performance, the average day, is somewhere in this distribution. In fact, it is right here. But as you see from this chart, it really doesn't describe the majority of the days, where the average is not representative of free flow conditions, and it's certainly not representative of what oftentimes is a very long tail to the right of the distribution, with the highlighted area that's labeled as % trips failing, based on some threshold travel time. So by repeating the analysis multiple times, 250 times, we can generate this distribution, which sometimes also is represented in the form of a cumulative distribution of travel times, and you may have seen these in some reporting, where the same performance measures that are part of the probability density function can also be found in this cumulative distribution. So starting to relate this back to some of the performance measures that Federal Highway will talk about in their webinar on Thursday, and that you may have seen. One of them is what's called the level of travel time reliability, or LOTTR, which is really a ratio between the 80th percentile travel time index and the 50th percentile travel time index. So it's really 2 points along this distribution, which each correspond to a travel time or travel time index, which are then converted into a ratio. So the LOTTR is defined as the 80th divided by the 50th percentile TTI. In this hypothetical example, that ratio would come out to about 1.44. That may not mean much unless you have some experience doing reliability analysis, but it's really intended to illustrate that the HCM can really directly generate some of these performance measures that are now part of the mobility rule for Federal Highway, and that are directly derived from this travel time distribution. So the FHWA Map 21 FASTECT, as well as really any of the other reliability performance measures, can be directly derived from the outputs that are now part of the HCM 6th edition. But the HCM doesn't stop there. In addition to quantifying the reliability, it also now has procedures that then take those strategies into consideration. And so there's a few examples shown here between ramp metering, part-time shoulder use, HOV and hot lanes, variable speed limits, and a host of other strategies. These can all be modeled as part of the HCM and then can be included in the performance analysis. So the way the method would then work is each of those 250 working days is assigned one or multiple of these strategies to really see what the impact, not only on the average day, but also on the whole year reliability performances of these strategies. And when it comes to making investment decisions and taking the travel time distribution and dissecting it, that becomes really, really powerful. And here's another slide that I've borrowed from Federal Highway, really trying to move from data and the understanding of the travel time distribution, which we get from our probe data, using tools like the HCM6 to identify what are the sources of congestion, understanding how the composite distribution represents different regimes, whether that's incidence, whether that's weather, whether that's work zones, whether that's demand variability, and then tying that understanding to the decision making of what the investment decisions are going to be in terms of either strategy or capital investments or some variation. So with this introduction, we'll now give an overview of the HCM reliability method and give a little more detail on how this works in the actual procedure. The overall framework here is the one used for freeway facilities. It works very similar for urban street facilities, where we're starting with our base data set. We're using a scenario generator that includes impacts of demand, weather, incidents, work zones. Those are translated into adjustment factors for demand, for capacity, for free flow speed, that are then run repeatedly through the core facility, whether that's freeway facilities or urban street facilities, to then generate the travel time distribution and derive the performance measures. Really all the reoccurring and non-recurring sources of congestion are included in that distribution, including the demand, the incidence, the weather, the work zones, as well as the demand surges. For the traffic demand variability, we're typically talking about a variation by day of the week, so Monday through Sunday, or for a weekday analysis, Monday through Friday, as well as the month of the year. And what's shown on the slide here is one of the default patterns for an urban freeway that's been included in the HCM 6th edition that gives a sense of what that variability might look like, with generally having lower adjustment factors for demand on Mondays and early in the year, and the peak that's shown here would be a Friday in July having really the highest demand. And this is where facility-specific data can also be used to populate the procedure. Similar for incidents, the incident data that's needed to populate the methodology is, one is the incident frequency that is described. It can be calculated using procedures like the Highway Safety Manual, or it can be based on field data, but populating the incidents as of by month of the year. The distribution of different incidents, there are some defaults included in the HCM, but what percentage of these incidents are shoulder closure versus one-lane closure versus two-lane closures. Characteristics about the duration of those incidents, the mean and standard deviation of those incidents, which can also be adjusted, for example, in a freeway service patrol type application to reduce the mean incident duration, for example. And then finally, a whole host of adjustment factors. Again, all of these are populated with defaults, but how do incidents impact the capacity, the free flow speed, and the demand on the facility? The characterization of weather events is very similar. Everything boils down to using capacity and free flow speed adjustment factor for various categories of weather. The HCM6 includes the defaults for these adjustments, as well as the weather probabilities by month of year and hour of day for the 96 largest metro areas in the US. So these have already been developed for you. Here's a look at these adjustment factors. The top table gives the CAFs, or capacity adjustment factors, by weather condition. The bottom table gives the SAFs, or free flow speed adjustment factors, as a function of the speed limit on the roadway, as well as different weather categories of medium rain, heavy rain, different snow, cold visibility categories. This slide shows an example of the weather probabilities. I've shown an example here for Raleigh, North Carolina, but there's the opportunity to include or to select one of 96 metropolitan areas in the U.S. And the likelihood of different weather conditions by month of the year in the different weather categories is based on 10 years of historical data and has been calculated already for you. And then also here shown are the same adjustment factors for capacity, free flow speed, and demand that I showed on the previous slide. Looking at work zones, the methodology can accommodate both scheduled long-term work zones, where, for example, a facility would be classified as having a work zone that lasts from, say, March until October, and that can be included in the scenario analysis. Also, the opportunity to use short-term maintenance jobs and categorize those as incidents, so both short-term and long-term work zones can be included. And just as the weather and incident affects, the implementation of work zone is done through both capacity and free flow speed adjustment factors that were developed in a recent NCHRP project 03-107 that have all been integrated to where work zones can now be evaluated for a single day analysis as well as part of a reliability analysis. And so again, the configuration of work zones is similar, where I can specify the long-term work zones here in terms of the start and end time, the work zone parameters, which segments are impacted. I can have multiple work zones. They could also overlap. Of course, on a long freeway or urban street facility, there may be multiple work zones over the course of the year. And then finally, how everything translates into these capacity and free flow speed adjustment factors. After specifying all these impacts, demands, incidents, weather, and work zones, a scenario generator is used in the HCM that's implemented in software that assigns these different events to the various scenarios. Some of those impacts are modeled deterministically. Those are the demand variations as well as the work zones that are user input. And then both incidents and weather events are actually modeled stochastically, so using a Monte Carlo kind of random number process where the scenario generator would randomly assign weather and incident conditions over those 250 working days of the year based on the underlying probabilities. What that means is that we now have some stochasticity incorporated into the HCM, where repeated runs of the HCM method may actually result in slightly different answers, similar to the way we're used to seeing for microsimulation. The HCM gives guidance on how many of these replications may be needed to really result in about 240 to 250 scenarios shown in the far right column that are needed to fully specify the reliability distribution. So a typical default analysis would be an analysis over a 12-month or full year analysis for the 5 working days of the year, 5 weekdays. We recommend, the HCM recommends 4 replication to result in about 240 scenarios, which essentially means that, for example, a Monday in January is modeled 4 times, a Tuesday in January is modeled 4 times, and so forth, to come up to about 240 days out of the year. If the analysis period is shortened to, for example, where we might only look at a summer analysis for 4 months over the summer, so going to only 4 months, we then recommend going to 12 replications. And this is something that in the software implementation can be adjusted relatively easily. Based on that scenario generation process, each of those 240, 250 scenarios then gets assigned a series of these different events. Here is shown a facility of 10 segments over 12 analysis periods, so 15 minutes, so this is about a 3-hour analysis. And what's shown here is about a 45-minute rain event that affects the entire facility, then an incident, a 2-lane closure incident in segment 8 starting in period 5, and then finally a shoulder closing incident that only lasts about 15 minutes. So each scenario can have a number of combinations and variations of non-recurring congestion events based on the underlying probabilities. All that process is automated, where that core HCM facility method is then applied and repeated 240 times. The performance measures are extracted, and then a software implementation would generate the travel time distribution, which then can be used to extract the necessary performance measures. So here's just one potential cumulative distribution with the dashed lines here representing the 95th, the 80th, and the 50th percentile travel time index to normalize the performance across multiple facilities. So this is one potential distribution, but it really can look very different depending on the type of analysis that's being performed. And from that distribution, there's really a whole host of performance measures that can be extracted. Some of them have been used in a lot of the SHARP 2 research to describe reliability and variability of travel. Some of them are now used directly in the rulemaking, as illustrated earlier, like the LOTTR. The HCM 6th edition then gives, moving from that framework that I introduced earlier, from data to decision, the HCM actually includes some of these illustrative effects of different reliability analyses, and I'm just sharing some of these here to illustrate that the HCM is actually sensitive to some of these changes. So for example, what's shown here is a facility where the black line represents only the recurring congestion, and then the various dashed and dotted lines represent the reoccurring congestion plus impacts of incidents, weather, or then incidents and weather. And you can see how the reliability distribution shifts to the right, meaning it spreads out more and more. And if you look at the 80th percentile travel time index, you, for example, see that the 50th percentile isn't impacted much. The 80th percentile keeps shifting to the right, which means that LOTTR performance measure would continually increase as we consider more non-recurring sources of congestion. The same is true for the ATDM analysis, where in the HCM 2010 we were able to evaluate the effects of ATDM on a single scenario, but we now can include the ATDM effect in a reliability whole year context and then derive the performance measures as part of the ATDM. The way the method is set up, the ATDM strategies can actually be be bundled, so where multiple ATDM strategies are combined into an ATDM plan, and that the analyst can then decide which plan gets assigned to which scenario, to where, for example, an incident management plan is only assigned to scenarios that actually include incidents, or maybe a snow removal strategy is only assigned to those scenarios that actually occur in the winter months when snow actually occurs. So it's quite a complex process, and it gives a lot of flexibility to the analyst to set up these different ATDM bundles to specifically target the sources of non-recurring congestion that may be present in a facility. And to again illustrate some of these effects, so here's a hypothetical example, again going from a facility that has about 1,050 incidents per 100 million VMT, and using some procedures in the Highway Safety Manual, for example, that result in some crash collision reductions. Here's a sensitivity analysis of what if we can reduce those incidents to 700 or 350 incidents per 100 million VMT, and you see how the distribution ends up shifting to the left, meaning it becomes more reliable. It's a tighter distribution as we reduce the number of incidents, which is the way we would expect the effects to be. Here's another example of looking at a hard time shoulder use example, going from a base case, the black line here, with highly unreliable travel, and then essentially implementing a short-term capacity improvement in the form of a hard shoulder running or a part-time shoulder use that really can greatly enhance the reliability without resulting in the same capital investment that we would have from a general widening of the facility. So bringing all this together to now a sample facility, this is an example problem in the Highway Capacity Manual to illustrate these effects. So a freeway in this case with 11 segments, and you see some level of service F. We can now look at how not only a geometric improvements, let's say a bottleneck mitigation where we widen segments 7 through 11 at the end of the facility, but how improved incident response time, reduced crash rates through a safety treatment, or then some demand management that actually promotes peak spreading, where the peak is distributed, starts earlier or lasts later, but is less severe. And we can look at how the various reliability performance measures then change as a response of these different treatments. And this is an example that Rick will pick up later again in his presentation, but I at least wanted to introduce this concept that we're going from not only describing the average condition and the base conditions, we're looking at the reliability performance, but then we're tying that also to treatments and strategies where we can compare capital investment as well as different strategies in a cost-benefit framework. And with that, I will hand it over to Rick to talk a little bit more about specific applications of this methodology.
Thank you, Bastian. Let me get myself set up here. All right. I'm going to actually walk you through just one case, because time won't allow us to go through multiple cases and applications, but I wanted to walk you through the steps of one case and give you pointers along the way so you can see where the challenges are and where the solutions are as we go along in this reliability analysis. So, if you will bear with me, I wanted just to motivate you folks one more time why you go to the trouble of evaluating reliability. The reason is it opens up a whole new world of options for you to address congestion problems. Transportation system management and operation strategies. If you can't solve a capacity problem the traditional way with more lanes, at least with TSMO, TSM, and O, you can identify some highly cost-effective solutions that you can implement in the short term and maybe squeeze a few more years of service life out of your facility by using TSMO to increase your whole year throughput efficiency so you get more capacity over the course of the year, even when challenged with adverse weather and incident conditions. Further motivation, as Bastian mentioned at the very start, is the Federal Highway Reliability Monitoring requirements. The 2015 FAST Act required them to establish those requirements. They just recently published their final rule for performance management measures for the National Highway System, NHS. If you're a legal bent, you can go find it under the Code of Federal Regulations, Chapter 23, Part 490. And among the various performance management measures, they specify there's reliability measures. And so a question that you may be posed by your bosses or your decision makers is, will the agency's capital improvement program help or hinder it in achieving its performance objectives per the FAST Act? So, 2 good reasons for considering reliability. It's a good idea, and you'll have to anyway. So that sums it up really quick. So let me walk you through an example application of how, just sort of elaborating on the analyses that Bastian was describing to you earlier, but giving you some of the more insights in the various steps along the way. So we've set up this example problem for you. The agency's systems reliability performance has deteriorated, as for most agencies, over the last few years. The new federal highway rules require you to establish a reasonable reliability objective that you can achieve with your proposed long-range transportation plan, your LRTP. So what can the agency's LRTP be expected to achieve? That's the question in the way of improved reliability over the next. And for those of you who got the handouts before the presentation, I've made a correction, so it isn't 5 to 10 years. We're talking about 20 years in the future for an LRTP. And the supplemental question is, how might the LRTP be tweaked with TSMO strategies, TSM&O strategies, to deliver the desired reliability improvement? So let me walk you through how you can use the Highway Capacity Manual to answer that question, those questions. Until Sharp 2, the only way to predict reliability was to use microsimulation. You would code and calibrate a microsimulation model, you develop a set of incident weather scenarios, you'd run the simulation model many times, and you'd pool the results. Now with Sharp 2, as implemented in the 6th edition of HCM, the practitioners, you folks can now have a highly cost-efficient tool for predicting reliability effects of infrastructure investments. So here's the steps to applying the 6th edition of HCM for reliability. There's 8 steps. First, you define your measures reliability. You then gather data for your analysis. You calibrate the model. Yes, we do calibrate the Highway Capacity Manual model. We haven't historically done that in the past, but it's recommended practice now. Step 4 is run the reliability analysis for your baseline conditions. Step 5, evaluate the results. Step 6, select your mitigation measures, your TSM&O measures, or other measures, and then rerun the HCM for those alternative that includes those measures, and then evaluate the results. So I'm going to give you some insights as we go through each of the steps. First of all, setting the reliability performance measures. Step 1. First thing is that HCM can't do the entire system, say for a metropolitan region, all at once, but you can do individual freeway facilities or street facilities. So for evaluating a long-range transportation plan, first step would be to identify those facilities where you're proposing some kind of improvement, and then use the HCM to analyze the impact of that improvement on your reliability for that facility. Once you've done that, well, let's not jump ahead here too fast. And then the other step, you identify which facilities to analyze. The next part of step 1 is to compute the Federal Highways Reliability Performance measures. Now, actually, you can pick many performance measures besides the ones Federal Highway recommends or has identified. And in fact, I recommend you do that. But since you have to report FHWA's measures to FHWA, if you're a state DOT or an MPO, local agencies don't have to worry about that just yet. And Federal Highways has established 2 reliability measures. So we're going to show you how to use the HCM to do that. But really, as Bastian said earlier, you can get any performance measure you want because the HCM produces the entire travel time distribution, and you can choose to characterize that distribution with any set of performance measures that you desire. So Federal Highways has picked 2 reliability measures. They want to know the percent of the interstate highways within your agency's jurisdiction that have reliable travel times. And they want to know the percent of non-interstate national highway system, NHS, facilities or segments with reliable travel times. So those are the 2 measures Federal Highways wants to hear back from state DOTs and MPOs. So what do they consider to be a reliable facility? They use the performance measure, the level of travel time reliability, the LOTTR, which is, as Bastian has told you, the ratio of the 80 percentile travel time to the 50% travel time. And that Federal Highways asks you to compute that over 1 year's worth of weekdays for AM peak, 4-hour peak, midday, I think that's a 6-hour if I'm adding it up right, and then PM peak, another 4 hours, and then for weekend days, they want a 14-hour. Then they define a segment as being reliable if the ratio of the 80 percentile travel time to the 50% travel time is less than 1.50. So in that earlier example that Bastian gave you where the LOTTR was 1.44, for Federal Highways, that would be considered reliable. However, you're an agency, you get to decide what you think is reliable, but when reporting to Federal Highways, you use what they consider to be reliable. And then as you compute the reliability for each segment, the performance is length-weighted to get the percent of the entire system that is considered to be reliable. Okay? So here we are again with the travel time distribution that the HCM produces and all the possible performance measures you can pick. And one thing we wanted to point out again and again and again is that, yes, any measure you pick, we can give you an answer for. So, of course, the fast stack mobility measures can be derived from this distribution. Let's move on to step 2. I mostly put this chart together just to give you a perspective on how much data is required for reliability analysis and how that compares to a standard 1 day only, 1 peak 15-minute period, 1 peak hour analysis. And so I've got 2 columns here. Left-hand side is conventional HCM peak hour analysis. Right side is HCM reliability analysis. So for conventional analysis, you need lane widths, ramp density, percentage heavy vehicles, terrain type, number of directional lanes. You see the works there. And then for reliability, you need some additional information, which is the variability demand, incidence and crash frequencies, severe weather frequencies, and work zone frequencies. Now let's start to break down this list. It isn't as bad as it looks. Some parts are hard, but some parts are not so bad. If you look at the conventional analysis, the highway capacity manual provides you a lot of defaults for a lot of this. So you aren't going to need too much more unless you have some unique conditions besides the number of lanes, the demand, and the length of the segment. So demand, distance or length, and the number of lanes, and then you can default, assuming your facility is fairly standard, most of the rest of life. Now when we talk about reliability analysis, there's those additional data items that can be hard to get, but as Bastian pointed out in his earlier presentation, some of this is already provided to you either through the tool or through the highway capacity manual itself. So variability demand, you would often need to go to a continuous count station to get that. Many of the larger agencies have that, smaller agencies may not. But the tool that Bastian was showing you earlier in his slides, there are some built-in demand distributions that you can use if you don't have something better to use locally. For incident and crash frequencies, that's pretty much you're going to have to bring that to the table. You need to pull that from your accident records and any incident logs you might have, but you're going to have to bring that to the table. I would recommend that. And then for severe weather frequencies, as Bastian mentioned, we've already pulled together how many airports that was, 90 some odd airports in the United States. And so we've got 10 years worth of data already built into the tool and to the HCM. So you don't necessarily need to bring that to the table. And then finally, work zone frequencies. Frankly, you have to go into your own agency files and decide what your work zone frequencies are. So that's the data. Much of it can be defaulted. Much of the harder stuff is provided for you. Some of it you still have to come up with for your specific condition or your specific application. Step 3 is, okay, you've got all the data, you've decided on your performance measures. Now you need to calibrate the highway capacity manual model for recurring congestion where there's no incidents and no bad weather. And this is to make sure that your reliability projections are more accurate than they would be otherwise. We found it to be valuable to calibrate the HCM for recurring congestion, calibrate the free flow speed, compare what the HCM, compare what you get in the field with what the HCM has as defaults for different conditions, compare the capacity of the HCM estimates to what you measure, what you see in the field, And often you don't need to measure that directly. You just you look at where are the queues, and if there's a queue, then at the downstream end there's a bottleneck, and whatever the flow is in that bottleneck, that's the capacity. So then you can make some adjustments that way. And then finally, you will need to adjust the demands a little bit, because most of us get demands from counts, and counts are not always equal to demands, especially when you got congestion. So there's some calibration. Don't get too scared about this. There's a whole chapter on in the high capacity manual about how to do this. I've pulled a little diagram off there on the right of the slide, and that's diagram, and the various steps are explained in the high capacity manual. So here's an example. There's calibrating the high capacity manual for recurring condition, but you can also, if you have the National Performance Monitoring Research Data Set, the NPMRDS, if you have access to it, and all state and MPOs have access to it courtesy of the Federal Highway License. You just need to sign a license agreement with them, and then you have access to the NPMRDS. You can use that to double check your reliability estimates, and sometimes that can be pretty valuable in terms of you might find that your information incidents may underestimate incidents. You may have more work zones than you realize, something like that. And so here's an example where the team has gone through and compared INRIX data to the highway capacity manual and made some adjustments to the reliability numbers in the various steps of the calculation to get this distribution. And you'll note we have a little peak there way out at the travel time TTI index, travel time index. That's the ratio of the actual travel time to the free flow travel time out at 3.5. And that's acceptable, because often when you're using monitoring data, some of those extreme cases tend to get thrown out because they're considered to be erroneous or not representative. And so in our case, we felt it was acceptable to have HCM predicting a bit more of these extreme conditions than maybe INRIX does, because there's some smoothing going out, and sometimes it's very hard to tell whether it's a stopped vehicle or somebody or a vehicle parked on the side of the road. Those are hard to tell. So that's why we allow some of that. Oops. Step 4 then is to actually run the analysis, and that is pretty simple because the software tools available will take care of that for you. You run it for Federal Highways purposes, 4 different analysis periods, or study periods of the week and the weekend. And a couple suggestions here, a couple pointers is the HCM methodology is not restricted to the length of time you can do the analysis. You can do an infinitely long, you can do 24-hour analysis if you so desire using the facility method. But most software tools don't allow that. They aren't dimensioned for something that large. So if you find yourself challenged, the FHWA wants 14 hours analysis for a weekend, maybe pick a representative 4-hour period and then run your HCM analysis for that. Maybe pick the 4 highest hours of the weekend period, something like that. Step 5, you run the analysis, and as Bastian showed you, you get those results. There's the same chart I think he had. I think I pulled off a slightly different chart, so I have slightly different numbers here. I have a 80 percentile TTI travel time index of 2.3, a 50 percentile of 1.7, and the ratio of the two gives you the LOTTR 1.35, which for Federal Highways would be a reliable facility. One thing I want to point out is that by necessity, there's a difference between how the highway capacity manual computes reliability and how Federal Highways asks you to monitor and report on reliability. NPMRDS data and INRIX data is by segment. And so it goes, they often go from interchange to interchange or from ramp terminal to ramp terminal. In the case of the highway capacity manual, we report for the facility. And part of this was driven by the need. We're doing a stochastic analysis, and results are more dependable when you analyze a lengthier freeway than if you analyze an individual segment between 2 ramp noses, 2 ramp terminals. And so, but if you really wanted to, I guess you would have to convert the HCM facility results into segments and then do your length-weighted weighting. But our recommendation is just do the facility analysis. This is forecasting. This is planning. You're trying to decide if the LRTP will get you in the right direction. And I wouldn't go to the trouble of then breaking down the facility into segment results for a strict segment-by-segment comparison. In fact, I would not recommend it. Step 6. Okay, we've done the baseline analysis. We've gotten some results. We found our facility was reliable for the federal highway definition. However, for the sake of this example, I'm going to assume it's unreliable, and we'll just walk you through some of the steps of mitigating the unreliability. And so where do you go for your TSM and O measures? Well, there's a Federal Highway Guidebook, a primer, Designing for Transportation Management Operations. Go there. It's downloaded for free. It's electronic. And in there you get a whole menu, a cornucopia, if you will, of TSM and O measures. I've only listed the first dozen or so there. I ran out of room on the slide. There's a lot more you can go into. So pick out your measures. I would recommend you group them into alternatives, much like what Bastian did when he was showing you the earlier analysis. And so you have your baseline analysis. Then you take your TSM and O measures and group them into maybe incident management, safety treatment, and demand management. And then you might have a capacity improvement, a geometric treatment alternative, which might mitigate the bottleneck on segment 7-11. So here's the example. We've got a baseline plus 4 alternatives for a total of 5 different HCM analyses of reliability. So you use the tool, rerun it, and then you evaluate results. And I'll be the first one to point out to you that there's a challenge for you folks. You're going to have the opportunity to apply your professional judgment, because there's a lot of TSM and O measures that are so new in the United States, we just don't have much data on how effective they are. Where we have data, we've summarized in the Highway Capacity Manual, and we give you, here's what the effects are. But some of the more advanced measures that you may choose to try, there just isn't enough data in the United States for us to say definitively what the effects to expect. And so you have to apply your professional judgment to say, well, how will demand management affect demands? How will incident management affect capacity and free flow speed? Or not free flow speed, but capacity. How quickly will that incident management program clear out incidents compared to what it is now? You will have to figure that out using your professional judgment. We've set up the framework for evaluating effects, but we don't provide a full set of numbers that you can use. In Chapter 37 of the HCM, we give you what we can find. It's the ATM supplemental chapter. But frankly, there are measures that you're going to try and want to analyze that we just don't have enough data yet to give you an answer, at least on an actual basis. So, step 8. You've applied those analyses. Actually, Bastian did this work. I'm just copying his chart here. And just there's a probability distribution on the left, a cumulative distribution on the right. The blue is after applying the measures. The red is before, the baseline. And so this is one of those 4 alternatives that we had looked at. So anytime you push those curves or those bars to the left, you're making things better. So you can see we've made it better. One nice thing with the HCM analysis and the tools that we have is that you can go in and look at, well, why did this scenario not get as good as I thought it should have? I did this incident management program and it didn't do me very much good. Well, you can go into the individual results and start to see what is going on. In this case, this is looking at an alternative, comparing it to the baseline. Before is the baseline, after is the with the alternative. I forget which alternative it was. And vertically, we've got time, which is increasing as you go down, and then distance is off to the right. So we're going down the different segments of the freeway as you go to the right. And in essence, our mitigation measure has actually hasn't eliminated queuing, but it makes it so the queuing starts later and it clears sooner for many of the segments of the freeway. So this is where you're using reliability analysis when the public says, well, it's F before and F after. Why are we bothering with the expense of this? Well, here's where you can show, well, it's going to start later and it's going to last, it's going to end sooner. And so that's a definite benefit. And you can see there's quite a bit less red on the after diagram than there is on the before. So here we are coming down to the end. We've evaluated the various alternatives, and then we have our selected performance measures. And so I've included our traditional measures, facility mean speed. Often we folks will report that. The mean vehicle hours of delay, that's VHD, and our 3-hour study period, at least 3-hour study period I was looking at here. And you can see that the bottleneck treatment is among the best for facility mean speed, is the best, but all the alternatives we looked at are better than the base condition. The same thing for the vehicle hours of delay. The bottleneck treatment is the best of all the alternatives you look at, and they're all better than the base condition. And then I would point out, this is just looking at operations. On a cost-benefit perspective, there's a good bet that demand management may be your most cost-effective option. But in terms of total operational benefits, it looks like bottleneck treatment's the best. And then we have our 80th percentile travel time index and our 50th percentile travel time index. And then you take the ratio of the two, and you see they've all improved. All the alternatives have improved it over the baseline condition. And then you have the level of travel time reliability, the federal highway performance measure, and you can see the bottleneck treatment is the best of the group. But I wanted to point out with a couple question marks there. There's always little surprises that come up when you use numbers to do your performance management. In this case, what we're seeing is that incident management and safety treatment actually made the LOTTR worse. I mean, they're all acceptable. All those numbers are acceptable. But it actually made it worse, and that's the danger when you use a ratio as a performance measure, because the ratio, you can change the top part and the bottom part, and if the bottom part changes more than the top part, you end up, things can look worse when actually everything is better. So this is why I encourage you to use more than just the federal highway performance measures for reliability, so you can get the full picture. So it's one of those things you have to watch out for. In this case, incident management and safety treatment caused a higher proportional improvement in the 50th percentile TTI than it did in the 80th percentile TTI, and that's why the LOTTR got worse with those two alternatives. So, now that I've given you a lot of food for thought, I'm just recap real quick. Using HCM to evaluate how an agency can best achieve its reliability goals, that's what we've been talking about. You can do it in 8 steps. The first 5 are all related to the baseline analysis, and then the last 3 are where you're trying your alternatives and evaluating the results. And so with that, thank you very much for your attention. I'm going to change this back to Bastian.
Okay, thank you, Rick. You've just sat through a little bit of a whirlwind of lots of news on HCM methodologies and how you might apply all that, and really in many cases quite fundamentally changing the way we are evaluating strategies. Some of you may have been exposed to these methods through the SHARP 2 program, and especially their implementation program, where several state agencies have been testing and exploring these methods, and so that's another really good resource. So the IAP Implementation Assistance Program out of the SHARP 2 project gives some really good examples of some of these methods that were developed to predict reliability. Before we go to questions, just a few slides to kind of sum up everything we've talked about today. Some of the benefits and advantages of the method, really in terms of reliability, the fact that any of the MAP 21 FAST Act performance requirements, as well as other performance measures, can be derived directly out of the HCM methodology and can be done so very cost effectively. So moving from a traditional facility analysis in the HCM to doing reliability, yes, requires some additional data, as Rick pointed out, in terms of the demand variability and the incidence, but in some of the agency testing that we have gone through, it does not come close to the alternative, which is taking a simulation model and calibrating it for 250 working days with different weather and incident effects, including the question of how do you even model weather and work zones and incidents and simulation, which really hasn't been very well documented at all. So the fact that the HCM has defaults for the capacity and speed adjustment factors, as well as the underlying probability, to really encompass the various sources of congestion on these mobility performance is quite powerful. And really, even if it, as Rick mentioned, it's, why do it as one, well, we have to, and the second and it's a good idea to do it, it really matches up with drivers' own daily driving experiences. And all of us have been in the situation of, planning at what time we need to leave in the morning to make sure we can still get to work or drop off the kids or run errands or whatever it is. And so we're really planning for reliability on a day-to-day basis. And depending on where you're located, you have a more or less reliable trip, and I bet that that's reflected in your travel choices. And so it's quite powerful that we can now relate to that. And then from an agency investment and the kind of the planning process and the long-range planning process, really selecting the appropriate treatments is really critical as well. Moving beyond a capital investment towards the TSM&O type strategies is really powerful. And then again, how else to quantify the impacts of strategies that are geared at unreliable travel? How do you use a one-day simulation tool to quantify that? The effectiveness of those strategies. So really the seamless tie-in with the reliability method and this active traffic management, giving these non-construction options and tailoring the strategies to scenarios that we're testing, the snow removal strategies in the winter months and the work zone management in the summer months, and maybe the ramp metering on a year-long basis. There are some challenges with this method. There are still, for those of you who have used the HCM freeway facilities methods, there are some limitations in the core method, including, for example, interacting bottlenecks when two queues begin to encroach upon one another, or if we have a queue spillback from a congested off-ramp where the arterial system spills back onto the main line. Both of those applications are actually being evaluated in research that is ongoing or about to start. So as improvements to the core facility method come online, they also will then make the reliability method even more robust. The data does present challenges, and the HCM includes some guidance and defaults on where the data comes from. But it frankly is something that agencies really have to gain some experience with and exchange lessons learned and begin a better understanding of what defaults can we use, what national defaults, where do we maybe develop state-level defaults, and at what point do we really need facility-specific data. And at this point, the method is really confined to that single facility. So that can be a freeway or it can be an urban street, but it really has not been set up yet for a system-wide analysis or a corridor type analysis, although again there's research ongoing through the NCHRP effort to explore just such an expansion, and my prediction is that it's really just a matter of the right software implementation to go from our current facility framework to applying these reliability prediction method for an entire metropolitan area, maybe even as an integration and extension to a travel demand model. These methods are computationally efficient enough to where they could be performed on a large-scale basis. And then finally, the challenge, Rick mentioned this, that some of these ATDM or TSM&O strategies, some of the adjustment factors are based on limited data because these strategies are so new in the United States. And so as, again, more strategies are implemented, more data are being collected, we can also refine these calibration factors for capacity and free flow speed. But these assumptions will have to be made regardless on what the tool is, and at least the HCM has some clear guidance on how to do that. I wanted to mention these two open source software tools. You have seen screenshots of these tools throughout the presentation, and I wanted to make sure that I highlight them. There's two tools that were developed by North Carolina State University, the ITRI Center there, one called FreeVal and one called StreetVal. The first being for freeways, the second for urban streets. Both of these were developed as part of the HCM 6th edition through funding by Federal Highway Administration and are therefore open source tools that are available. So performing the freeway reliability or urban street reliability analysis, Federal Highway recognized that without software it's infeasible to do that. And so these are computational engines. They don't have software support or a licensing contract or user support the way a commercial tool has. Luckily, there are a number of commercial software vendors that are also embracing these methodologies and are implementing them in their commercial tools. But in the meantime, these two engines are available for free on HCM Volume 4, and that can be used for you and for agencies to explore the use of these methods, and also for the software vendors to really benchmark their tools against these two tools, which were the ones that were used to develop the methodology in the HCM, as well as develop all the example problems. And so where you get these, it's a plug here for hcmvolume4.org. Which is the electronic volume for the HCM 6 edition. It contains additional methodological detail, interpretations, errata, applications guide, and as part of the technical reference library, if you go to Chapter 11, Freeway Reliability Analysis, you'll find the FreeVal engine as well as the FreeVal user guide posted there. Same thing if you go to Urban Street Reliability Analysis, which is Chapter 17, you'll find the StreetVal tool posted there. Also, if you would rather not read the user guide but go through a video, there's a YouTube page that was set up by ITRI at NC State to compile a series of training videos for both FreeVal and StreetVal. So the URL is shown at the top of the screen there. Again, these are available for you to explore the use of these tools and test them while the commercial software is being developed and becomes available hopefully in the near future. So that brings us to the end. Thank you for your attention to this fourth webinar, and with that we'll turn it over to any questions.
Great, thank you so much. I will start reading the questions that have come in. Hold on one moment. Okay, so the first question that has come in is the image shown on slide 26 from HCS software, or is FreeVal a separate software? And presenters, if there's at any point, if you'd like to refer to any of your slides, I can give you back control.
Okay. Yeah, so I'll take that question. So slide 26 and really any of the other screenshots, these were all from the FreeVal engine, which is the free tool that's available on Volume 4. The question about HCS software, my understanding is that HCS, which is developed through the McTran Center at the University of Florida, also has a implementation of the freeway facilities and the reliability methodology. I don't know what their interface looks like, but presumably the two tools would be comparable. But all the screenshots that we used in this presentation were from the FreeVal and StreetVal tools.
Great, thank you. All right, the next question that has come in. So agencies will need to perform more traffic counts or for longer duration, it seems. Are DOTs and MPOs equipped to do this? They continue, I know some of us larger cities are not. It seems newer hardware can count easy through many of us, or sorry, it seems newer hardware can count easy, though many of us are still replacing obsolete equipment.
Hey, Bastian, this is Rick. I'll answer that one. Yeah, the quick answer is yes, agencies will need to perform more traffic counts, but you may not need to do all the detailed counts. For example, you might do a turning movement count at an intersection and then put out a machine for a week or two to get a variation of traffic over the course of a couple of weeks. And then you might go to an HPMS, Highway Performance Monitoring Station, HPMS station, to get, say, a full year's worth of data and say, well, if the traffic was this high in January, I know in July it's going to be 10% higher, something like that. Bottom line, though, is, to get the greater precision, agencies would need to do more counts for longer duration. But there's technologies out there as well. For example, with some of the newer controllers have the capability to store counts from the loop detectors for the approaches to the signal. So there's possibilities to acquire that data.
Yeah, and if I could add to that, in the implementations that we have done of this method and working with some state agencies across the country, we've typically used some of the permanent count stations that are available, downloading the year's worth of data and then extracting these factors. It's certainly a new way of looking at traffic data, but it's becoming standard practice very quickly. The other thing I wanted to add is that it really also depends on your judgment a little bit as the agency, let's say for a state agency, to really know what your traffic patterns are, which are likely to be very different in urban areas compared to rural areas, compared to maybe areas that are served by heavy tourism traffic. And so really, if you have a major metropolitan area, I would think that you wouldn't need more than maybe 3 or 4 of those permanent count stations to develop your annual profiles, because I wouldn't expect for a city, for different parts of the city, to have drastically different patterns. But then as you move out of that city, or as you move into a heavy tourism area at the beach or in the mountains or whatever or theme parks, whatever the destination may be, then that facility may warrant some specific counts and some specific calibration to capture the demand variability.
Great, thank you. The next question that we have it does not seem to address the impacts of diverted traffic, both its travel time and the additional travel time that might be forced on other flows. This was at about 4 o'clock.
Yeah, I can tackle that one, I think. If I understand the question correctly, it is correct. The focus of the Hcm procedures for now is on the facility. So that may be a 10, 15-mile stretch of freeway, or maybe a little bit shorter stretch of arterial, and evaluating that in terms of its reliability. The Hcm currently is not a network tool, although there are some examples of where Hcm procedures have been plugged into travel demand models, for example. But yeah, for now the focus is on the facility level, not on the network level in terms of looking at diversion impacts and so forth.
Great, thank you. The next question that has come in: does the new HCM actually recommend use of the AASHTO Highway Safety Manual, and how influential are crash estimates on reliability, and has anyone done a sort of sensitivity analysis on that?
Shall I take it, Bastian?
Sure.
All right, and then you can add on. The Highway Capacity Manual does not actually recommend use of the Highway Safety Manual, but it would make a lot of sense to me personally, but that's not an official position. How influential are crash estimates of reliability? Has anyone done a sort of sensitivity analysis on that? I think some of the work Bastian has done might have gotten at that, but I haven't seen anything formal published on that. I think it'd be a great TRB paper. My hunch is crash estimates do have a big impact on reliability, and you have those incredibly severe accidents that close the entire facility, at least for a freeway. Those are so rare that they aren't going to affect your 80th percentile travel time. So it's going to be actually your incidents like breakdowns and maybe lane closures, the more frequent incident types that are probably going to have a more significant impact. I would rank them up there certainly with weather and demand variation. And then it'd be interesting to see somebody put some numbers to my gut feel about this. Bastian?
Yeah, we, and some of the implementation assistance program work that I've alluded to that we've been involved with, we did find that having facility-specific crash and incident data does seem to result in better estimates in terms of the calibration. Those data were actually easier to obtain than the traffic counts, because again, through some of the reporting that agencies do, the crash data were more readily available. Again, we're not talking about individual crash reports, we're talking about aggregated crash rates per 100 million vehicle miles traveled. So we were able to develop those for the facility and then got better performance. And to the tie-in to the HSM, I agree with Rick that that's really where it should go. The HCM recognizes that there are other what it refers to as companion documents. Transportation professionals use the HCM as well as these other ones. So I'm not aware of any actual projects that have tested that tie-in between the HCM and the HSM, but I agree that it's a great capability, especially as agencies are looking for safety improvements and their impact on reliability, which frankly, it may be evident in the data that really the unreliability of a certain facility is maybe because of a tight urban weaving segment, and that replacing that weaving segment with something else will enhance safety and therefore enhance reliability. And in order to predict that impact, there are crash prediction models that are part of the HSM now that could be plugged into those applications to then get the enhanced safety and in turn the improved reliability.
Great, thank you. Hold on one moment. We have many questions coming in. So the next question would be, it seems that the LOTTR uses traffic data from worst-case scenario cases. Is this accurate? If so, how do you make sure that you don't over-design? For example, end up with a freeway with 12 lanes when you really only need 6 lanes.
Yeah, the LOTTR actually uses the 80th percentile divided by the 50th, and I can only presume that the thinking from Federal Highway behind that is to avoid those extreme cases. So there's been research that has suggested that I'm aware of that the 80th percentile travel time is a lot more stable than, say, the 95th percentile, where the 95th percentile can be very easily impacted by outlier events that would then result in this over-design. So my guess is that that is where the 80th percentile comes from, to avoid exactly that potential pitfall, but I can't comment on the internal FHWA rulemaking process on where exactly that measure came from.
Great, thank you. The next question that has come in, can the HCM model capture variation in loss capacity based on the lane, inside, shoulder, middle, on the reliability metric?
Ashton, you're probably best for that one.
Yeah, I want to make sure I understand the question. So can the HCM model capture variation in lost capacity based on the lane, inside, shoulder, middle, and the reliability metric? The HCM currently does not have a lane-by-lane methodology, so all the analysis is done on the cross section, and so the reliability would not be reported separately for the shoulder lane, middle lane, or outside lane. However, the net effect on the cross section, that can very well be calibrated and should be calibrated, as Rick alluded to, based on field measurements to, for example, look at the bottleneck capacity and plugging that in through one of these capacity adjustment factors. So really the way the HCM is set up now is that there's a whole series of these CAFs and SAFs, capacity and speed adjustment factors, that can be used to calibrate the base capacity, to calibrate weather effects, incidence effect, work zone effects, truck effects, and so forth. And so, for example, taking the effect of a part-time shoulder use on the aggregate capacity across the section would be taking 3 times a full lane plus the shoulder lane, which maybe has a reduced capacity, and translating all that to a composite capacity across the cross-section of the roadway. I hope that answers the question.
Yeah, this is Rick. I would just add that the method is sensitive to the number of lanes closed by an incident, but it does its computation across all the remaining open lanes.
Okay, great. The next question. What was the rationale for using TTI-80 for LOTTR calculation as opposed to, say, TTI-85?
Yeah, this is Rick. You'll have to ask Federal Highways. That's their call.
Okay, thank you. The next question, what is the difference between facility and corridor on slide 68, third bullet?
Bastian, that's yours.
Yeah. So a facility in the HCM is defined as either the freeway or the arterial street. A corridor would be defined as a freeway with a parallel arterial street. And so the current HCM method in the HCM6 can evaluate either the freeway or the urban street. There's research ongoing now to look at a corridor methodology, or almost a mini system methodology, where performance on the freeway impacts the performance on the arterial street and vice versa, in terms of spillback potential, in terms of diversion, those kinds of things. So that is forthcoming. The research project number is 15-57 if you want to take a look at the description online. But for now, the HCM focuses on the facility, not yet the corridor.
Great. Thank you. How does the analysis handle highly congested corridors and have congestion for long peaks? Consistently congested corridors results in reliability, does it not? Any thoughts on this?
Yeah, it's a good point. So and I think it reiterates a point Rick made earlier about, there's really understanding the overall distribution in the decision-making process. We're moving ahead now to where we can quantify the travel time distribution, whether that's from probe data or whether that's through the HCM prediction, and then condensing it all down to a single number, I think does some disservice to all the data information we have just generated. But to answer the question on congestion, so the HCM method, and for those of you that maybe didn't attend the last webinar, which focused on the freeway facility method and its oversaturation module, but the HCM method is capable of predicting queuing patterns, tracking queue buildup and dissipation over multiple segments and multiple time periods, as well as evaluate that congestion over extended analysis periods. And actually in the FreeVal implementation, the full 96 time periods, which means 24 hours and 15-minute intervals, is possible. And in the last webinar that was broadcast in December, I actually showed some use cases of some nighttime work zone management and lane closure schedules and these kind of things. So the congestion effects are very much in there. But to your point, yes, as the base congestion increases, at some point the focus on the facility will not give you the true congestion impacts, because if an already congested facility has a full breakdown with an overturned tractor trailer, presumably the congestion is going to spill back across the entire network, which then really is beyond the capability of the HCM facility focus.
Great, thank you. The next question that has come in, sorry, hold on one moment. Is there a recommended number of years for crash history to be evaluated?
What do you think, Bastian? 5 years?
Well,
3 years?
Yeah, so I guess the official answer is the HCM does not specify, but I would say that the kind of standard practice for crash and safety analyses, looking at 3 years of crash data, for example, maybe with a preference to 5 years, does appear to make sense here as well. Certainly more than 1 year of crashes. I think a 3-year reporting on crashes is typical, and it seems like that would apply here as well.
Great, thank you. We have one more question that has come in. After that question, I will begin going over how to earn PDH credit. Again, for those who were not here before the webinar began, for that those instructions. So the last question that has come in, does the weather data only account for what is happening on a certain day, or can it account for the impacts on the following days? For example, would you need to do anything special to account for the weather-related impacts that happen on the day or week after a snowstorm where there may be snow, slush, or ice, depending on how temperatures vary or what response capabilities the agencies have?
Yeah, that's a great question. The weather probabilities that are used in the HCM method are based on the National Weather Service reported weather conditions. And those weather conditions are reported based on the precipitation, not on the current status of the roadway. So in other words, it really looks at the if it snows on one day, the weather probabilities would account for the precipitation on that snow day, but it would likely show the next 2 or 3 days as quote-unquote clear weather, and maybe then overestimate the results a little bit. My recommendation would be that this is a case where maybe some additional calibration is needed. So again, Rick mentioned calibration on the core facility level and then calibration on the reliability level. If you are located in a state where weather events are relatively rare, then maybe the HCM probabilities are sufficient, or maybe you adjust your one heavy snow day to actually correspond to 2 or 3 to get those effects correctly. But if you're in a climate where you have more frequent snowfall, I would really recommend to look at the calibration, looking at your reliability effects of how much it snows, and also what the resulting capacities are, because as drivers get more used to driving in snow and as you have better snow clearance equipment and so forth, really the effects are different in climates where you have frequent snowfall. So a way to think about the weather probabilities that were on slide 26 in the presentation is that those are precipitation days, and you could presumably calibrate those to get closer to these snow impact days that you alluded to in your question.
This is Rick. You might the weather data deals with what's falling out of the sky because it's airport data. It doesn't deal with what's on the ground. So flooding, snow levels, it doesn't deal with that. So how I would deal with that, if that's a significant issue, and it is for many of us, is I would treat it as an incident. I'd say, I've lost the lane. There's been a lane closure because of flooding. My right-hand lane's been flooded out. Or there's a loss of a lane because of snow removal. All the snow plows are piling in the right-hand lane, so I've lost a lane. So I treat it as an incident. So you would have to do it yourself. We don't have the weather data doesn't build that in for you.
Great, thank you so much, Richard, Rick, Rick Dowling, Bastian Schroeder, thank you so much for your presentations today. A lot of really great information. And thank you to the attendees today for joining us. One last time, I'd like to go over how to earn